Welcome to this tutorial series covering the workflow we designed to bring two-dimensional map and geospatial information systems datasets into three-dimensional virtual reality reconstructions. This is part one of a five-part series in which we will cover the entire process of working with the two-dimensional datasets and GIS software packages and bringing them into the Unity Engine program. Part 1 will be covering the essential programs and datasets you will need for the remainder of the reconstruction process, and where you can find these programs and datasets. This workflow was designed with the intention of being more accessible, cost-efficient, and less time-consuming than the previous workflows we developed. Please do not skip any parts, as it will be difficult to get the reconstruction to work accurately without each part and each step. To start, let's look at the software programs you will be needing for the process. The first and likely most important software package is a Geospatial Information Systems or GIS-based software. This tutorial program and process will be using ESRI's Arc desktop suite of programs, specifically ArcMap and ArcScene. As of this tutorial, ESRI's Arc Pro, a replacement for ArcMap and ArcScene, does not yet have all of the required aspects and plugins to make the process work. Additionally, while my experience with it is much more limited, QGIS, the open source GIS software program, does not seem to have all of the aspects required either. If you watch this series and know that these programs do in fact have these required parts, please let me know. In any regard, the GIS software will be how we create and modify the GIS two-dimensional and three-dimensional datasets and keep the accuracy of the reconstruction at the highest level possible. The next few software programs you will require are the 3D modeling programs. For the purposes of this tutorial series, we will be using SketchUp Make, a free architectural 3D modeling program, and Blender, a free 3D modeling and rendering program. Additionally, these programs are required for making 3D models of architecture, as well as converting the 3D models from one type to another. The final software package you will need is the Unity Game Engine, a free 3D rendering and game creation program. This software package renders them 3D models and allows users to create programs that are explorable in a first-person perspective. With Unity, there is also an asset store, an online virtual store where users can sell models, code, and attachments to other Unity users for their programs. For this process of the reconstruction, we will also require a Unity asset package, the Gaia asset package by Adam Goodrich, a set of procedural modeling terrain building assets that assist in the creation of our environment. For this process, these are all the programs you will need. To summarize, you will need ArcMap, ArcScene, SketchUp Make, Blender, and Unity with the Gaia asset package. Additionally, in combination with these programs, you will also need two types of data sets in order to reconstruct the archaeological sites and the environment around the site accurately. In this case, the two data sets that you'll need is one needs to be a LiDAR or a DEM or digital elevation model data. The other data set you will need are shapefiles showing the location, orientation, and potentially the footprints of structures, features, and artifacts that you will want positioned within your reconstruction. For this tutorial, we will be using shapefile data for Sulphur Springs, Oklahoma, a 1904 to 1906 tourist town that was bought by the government, relocated north across the local river, and converted into a national recreational area, which is how it exists today. LiDAR and DEM data sets will give us our topography and our height map. And this data can be acquired from a variety of sources. One of the largest resources for free LiDAR datasets within the continental U.S. is the USGS's Earth Explorer program, an online system for browsing a variety of databases and datasets, including LiDAR and DEM data, for anywhere in the world. However, the datasets that you can acquire here are either often incomplete or of too low of accuracy to be of use within these reconstructions. Another source for data can be found for U.S. states via state GIS programs. States, such as Oklahoma in this case, often have sites where GIS data such as LiDAR data, DEM data, hydrology data, and the like is freely available, and it is often of high quality and accuracy. In this tutorial, we will be using data obtained from the Oklahoma GIS site. Shapefiles that show locational data can be created or obtained from a variety of sources. The data used in this tutorial was created from a variety of methods, including archaeological ground truthing of the area, georeferencing a variety of maps, a U.S. Census map that shows the property blocks of the region in reference to the LiDAR data with a hill shade applied, and the use of historic maps such as Sanborn insurance maps that show the size, location, shape, and orientation of the individual structures. This process was developed in order to keep as much of the geospatial data intact from two-dimensional maps in ArcGIS software, all the way to the 3D reconstructions built in the Unity engine. To summarize this part 1 of this tutorial series, you will need a variety of programs, including ArcMap, ArcScene, SketchUp Make, Blender, and Unity with the Gaia asset package. Additionally, you will need 2 data sets: LiDAR or DEM data that shows the elevation of the region that you are reconstructing, and shapefiles that show the location of structures, artifacts, and features that you wish to incorporate into your reconstruction. Part 2 of this tutorial series will be covering how to prepare the 2 data sets for the process of converting them into a digital reconstruction.